Hi, students. This is Professor Gina, and I am going to make a short video showing you about um, scale factor. Scale factor is a number that we would multiply to get from a smaller version of a shape to a larger version, or vice versa. This implies that we have shapes which are similar, and similar shapes will have all of the corresponding angles being identical. That means any of the angles that are in the same location. And then the sides that are corresponding would be in proportion to one another. So for example, this side that I have here on the left, which is 4 inches, corresponds to this side over here on the left, which is 10 inches. And so if I want to determine the scale factor between them, I'm trying to figure out what it was, what number was it that I multiplied by to get 10. So if I divided both sides by 4, I have 10 over 4, or 5/2. So it looks like the scale factor in this case is 2.5. So if I were to take and say check 6 and multiply that by 2.5, I would get 15. And that shows that these two sides also correspond with one another. So the scale factor, again, is what's multiplied for any of the linear lengths, meaning any of the sides. Now, the question comes up, what if I were to compare the areas of these two? How does scale factor relate when I talk about the areas? The area of this shape is 24 square inches. And the area of this shape is 150 square inches. So what if I were to compare the areas here? Let's take 24 and see what the scale factor is for area. What am I multiplying by to get from 24 to 150? So the scale factor is 150 over 24. If I were to simplify this fraction, it is 25 over 4. So let's take a look at the comparison between these two numbers. This was linear, or raised to the first power, right? And this is squared, or raised to the second power. Because area is taking the length and the width and multiplying them together, that scale factor is being multiplied twice, or being squared. So when I go to a dimension that is squared, I'm going to take the scale factor and square it. If I took 5/2 and squared it, I get 25 over 4. Let's look at a second example. Scale factor can go both directions. The way that I was just looking at the scale factor was going from the smaller shape to the larger shape, but I could go in the opposite direction. What would the scale factor be if I went the other direction? Scale factor going this way, big to small. So that would be 9 multiplied by what? Gets me to 3. It looks like the scale factor in this case would be 1/3. So we can kind of see by looking at it, if I were to go this direction, the scale factor is going to be 3. And if I go this direction, the scale factor is going to be 1/3. Going back and forth, you can see that those scale factors will be reciprocals of one another, taking the fraction and flipping it upside down. Let's compare the areas of these two. Based on the example that we just did before, I think that the the areas are going to be, if the scale factor going from small to big is 3, then the area scale factor, I think that the area scale factor is going to be 3 squared going this direction. All right, what's the area here on the left? The area is pi times the radius squared, or 9 pi, right? Area over here is 81 pi. If I compare these two, going this direction, I would multiply by 9. And that matches up with what we think the scale factor would be for area. What if I were to compare the circumferences? Circumference is a linear measurement, so we believe that it should just be the scale factor. What's the circumference here? The circumference is pi times diameter, or in this case, 6 times pi. The circumference over here is 18 times pi. So if I were to compare the circumference going this direction, I'm going to multiply by 1/3, which is the scale factor going from big to small, right? All right, I want to do a couple of examples that are looking at volume, because volume is a 3-dimensional measurement. And so based on what we've seen in the last 2 examples, we're expecting that the scale factor for volume is going to be raised to the 3rd power. So let's find the volume of this shape. First, we need to find the measurements over on the right-hand side. The scale factor is 5/4, which is the same as 1.25, right? So to get all the measurements on the right, I'm going to multiply by 1.25. The length over here is going to be 12, which is the length on the left, multiplied by 1.25, which is 15 yards. The width will be 4 times 1.25, which will be 5 yards. And then the height is 8 times 1.25, which is 10 yards. All right, now I'll calculate the volume for each of these. The volume over here is 12 by 4 by 8, which is 384 yards cubed. The volume over here is 15 by 5 by 10, which is 750 yards cubed. Now, what I think, because volume should be it should be 1.25 raised to the 3rd power. 1.25 raised to the 3rd power. Ooh, that's a weird decimal. I'm going to write this in fraction form instead. Instead, let's write this as 5/4 cubed, which is 125/64. Yeah. So I believe that if I took this number and multiplied it by 125/64, I should get this number. Let's test that. Let's see. If I take 384 and I multiply it by 125 over 64, again, which is the scale factor cubed because we're going between volume, I get 750. So that checks out. If I were to calculate the surface area of these two, the surface area, scale factor, is going to be 5/4 squared because surface area is square units, or 25 over 16. So that's how the two surface areas would compare to one another. All right, I want to do one more example just showing you volume. So in this case, the scale factor from small to big is 3/2 or 1.5. So that means that the radius on the right-hand side for the larger cylinder is going to be 6 times 3/2, which will be 9 meters. And then the height will be 14 times 3/2, which is 21 meters. All right. What I'm going to do is I'm going to first figure out the surface area of the one on the left, and then I'll do the volume. So what is the surface area? The surface area is, I have two bases, so 2 times pi r squared, that'll give me the top and the bottom. And then I have all of the sides, which is the circumference, pi times diameter multiplied by the height, that'll give me all the sides. So the surface area is going to be 2 times 36 pi plus 12 is the diameter times pi times 14. So 72 pi plus 168 pi . 72 plus 168 is 240 pi is the surface area. All right. So I believe that the surface area over here is going to be 240 times pi multiplied by the scale factor squared, because surface area is a square measurement. So 240 times 3/2 is, I think that the surface area over here is 360 pi meters squared. We'll check that in a minute. The volume over here, volume is the base, pi r squared multiplied by the height. The radius was 6, so 36 times pi times 14. So I think that the volume over here is 504 times pi meters cubed. And so then using the scale factor, the volume over here is going to be 504 pi times 3/2 cubed. Oh wait, did I mess that up? I did. Error up here. Miss Gina just realized she messed up. Wrong. Going back for a sec. We'll come back here in a minute. This is wrong, right? I multiplied wrong. Okay. 504 times. This should be 170. Oops. 1701 pi meters cubed. Let me just double check that, 504. Yeah, okay. Let's go back. I made an error back here. I think I only multiplied by 3/2, not 3/2 squared. So let me do that again. 240 times 3 divided by 2. 540, did I do that right? I don't think I did that right. 540 pi meters squared. Okay, good. So let's check our work here. I'm going to calculate the surface area of this cylinder on the right. So the surface area is 2 times pi r squared plus pi times diameter times the height. So the radius is 9. This will give me 2 times 81 pi plus the diameter would be 18 pi times 21. This is 162 pi. This is 378 pi, which is 540 pi meters squared. And scrolling down, that checks with what we had here. For the volume, it's going to be pi r squared times the height, which is 81 pi multiplied by 21. And we get 1701 pi meters cubed, and that checks with what we had down here. All right, if you have questions, you can send me an email or send me a message on Canvas. Have a great day.